Have you ever climbed aboard an airplane and taken off into the sky? As the engines roar to life, you might have wondered, how does that massive metal tube, which looks like it shouldn't be able to move a plane weighing hundreds of tons, actually produce enough power to get us up there? And why is it so reliable and safe? And here's the surprising part. Jet engines are incredibly complex machines with some pretty neat tricks up their sleeves. Let's dive into how they work, step by step. Okay, so you've probably heard that jet engines are super complex and magical. But let's break it down to something simple, like blowing up a balloon. When you blow up a balloon and tie it off, what happens if you give it a quick burst of air? It zooms across the room, right? And just like that, a jet engine works on a similar principle. Here's how. A jet engine sucks in air from the front. Imagine your hand is the engine, and your other hand is pushing the air in. Easy peasy. Not too complicated yet, huh? Then, inside the engine, it mixes this pulled-in air with fuel. It's like when you mix baking soda and vinegar. It creates a reaction, but instead of bubbles, we get hot gases. Next comes the ignition part. The mixture is set on fire, kind of like lighting a match to start a campfire. This combustion produces incredibly hot gases. The final step is expelling these gases out the back of the engine with force. Just like when you let go of that balloon, it zooms off because all the air inside is rushing out suddenly. But instead of a balloon, the jet engine is pushing backward against this rush of air, and thanks to Newton's third law, for all you physics geeks out there, it creates forward thrust. So, in essence, a jet engine is essentially a giant high-speed balloon that shoots its air out really fast from the back end. And that's how it generates the power to make the airplane soar through the sky. What makes a jet engine tick? And how does it generate the incredible force that propels a plane through the air? And here's the surprising part. A jet engine has four main components: the compressor, the combustion chamber, the turbine, and the nozzle, each playing a critical role in this process. Think of it like a band, where each member has a unique job, but together they create a beautiful sound. The compressor is like the drummer, setting the beat by sucking in air and compressing it. The combustion chamber is like the lead singer, adding the energy with fuel, making the mixture hot and powerful. The turbine is like the guitarist, using the energy to generate power, and the nozzle is like the sound system, directing the energy outwards to create the thrust. Working together like a perfectly choreographed dance, these components produce the thrust needed to fly. It's a remarkable process, and understanding how these parts work together can help you appreciate the amazing technology that gets you safely from one place to another. So, let's take a closer look at each of these components and see how they work together in harmony. Vocabulary: compressor, combustion, turbine, nozzle. Okay, let's talk about something that might surprise you. Jet engines are actually quite efficient. Many people have this misconception that they're incredibly wasteful because they waste so much energy as heat and noise. But here's a truth bomb. Modern jet engines convert about 30 to 40% of the energy in their fuel into useful work. Think of it like this. You know how when you run your car, only about 25 to 30% of the gas you put in it actually makes your wheels turn? That's not too different for what a jet engine does. It may seem like it wastes a lot, but that's because turning all that energy into just moving the plane would be incredibly inefficient. And here's the surprising part. This efficiency is comparable to that of a typical car engine. Imagine if you could only use 25% of your gas for driving. The rest would turn into heat under the hood or noise from the exhaust. Just like in cars, jet engines get better at converting fuel energy into forward thrust with each new generation. So remember, the next time you hear someone talking about how inefficient jet engines are, you can nod knowingly and say, actually, they're pretty efficient. They might look wasteful on the outside, but inside, those engines are doing their job incredibly well. And for nervous flyers, here's the reassuring part. Jet engines are built to be incredibly robust and reliable, with multiple redundancies and safety features, making engine failure an incredibly rare event. And even when it does happen, planes are designed to fly safely on one engine. Think of a jet engine as a powerful but delicate tool. Imagine it like a high-tech blender, capable of turning a steady stream of air into an incredibly focused force. But just like how a blender needs multiple safety mechanisms to prevent leaks and overheating, so do jet engines. They have backup systems in place for things like oil pressure, electrical power, and even the bleed air that helps keep them running smoothly. Now, here's something most people don't know. When it comes to flying, planes are designed with a single engine failure in mind. It's like having a car that can still run on one tire. Yes, it's not perfect, but you can get home safely. Aircraft are engineered to maintain safe flight paths and even continue to the nearest airport if they lose an engine. Incredibly rare? Absolutely. In fact, the vast majority of flights around the world never experience any engine issues at all. And when there is a problem, airlines have highly trained crews ready with procedures that ensure passengers stay calm and the plane lands safely. So, remember, while jet engines are complex machines, they come with built-in safeguards and robust design. The safety features in place make it extremely unlikely for an engine to fail during flight, and even if it does, modern planes can handle the challenge with ease. So, to answer our initial question, a jet engine works by using a combination of air, fuel, and precise engineering to produce a massive amount of thrust. It's like an incredibly powerful fan that sucks in air at the front, compresses it, mixes it with fuel, ignites it, and then expels the hot gases out the back, creating forward motion. And here's the surprising part. Despite all this power and complexity, jet engines are incredibly reliable. Incredibly rare is a major incident, even more so on modern commercial aircraft. The reason? Engineers and airlines have spent decades refining these systems to be as safe as possible. So if you found this explanation of jet engines interesting, consider subscribing for more insights into the world of aviation. You'll gain a deeper understanding of how our planes work, making your next flight that much more fascinating and maybe even a little less scary. After all, now you know just how amazing and well-engineered these machines are.